Today we're going to discuss our classical probability and day one of this classical probability. So the first homework is going to be over just putting the problems into words. So that's all we're going to do, is just put the problems into words. And the questions are not going to ask anything about numbers. It's only going to ask about words. It's going to ask you how to do these different things. So I want you to describe using words on that homework assignment. And specifically, you're going to want to put in your problems the words and or. Because when we talked about before probability rules, we did the word and meant to multiply, and then the word or told us to add, and then subtract off any overlap. So we're going to use those same rules that we've done in the past, or that we used in the past. Let's put some marbles in this urn. Let's start off with, let's say, well, let's do a black ball, or two black balls. That's not black, that's purple. Well, two purple balls. Can you tell they're purple? And a couple of, better not use blue, it'll look the same. How about, we'll do two red balls. And then we'll do one black ball. See, the black is different enough from the purple that we can tell. Can we tell the difference between those? Okay, so we're going to be dealing with some problems about probability, and tomorrow we'll do actually the probability part of it. But today I'm just going to put it into words. That's all we want to do, is describe the situation using words. And specifically, we want to use the words and or. Because remember, when we're talking probability, the and reminds us when I'm doing this and that, then it helps me to remember that I'm just going to multiply. And then when I have that word or in there, you know, I'm going to pick this or that, then I'm going to add, and if there's any overlap, then we end up subtracting off. Today we're not going to have to deal with any overlap because they're going to be independent events. But this, when there's an or, then we're just adding those. Okay, so with that knowledge, we're going to want to use those two words within here. Let's start by just asking ourselves, how can we choose, or how can we choose two purple balls from this urn? Now, maybe we should decide how many we're going to pick from the urn to begin with. So, you know, when we get ready to choose out of here, maybe we're going to choose two balls to begin with. So we're going to choose two balls from our urn to begin with. And then I want to know, how can we choose two purple balls from there? Now, these balls in an urn problem are great for mimicking or representing when we sample from a population. You know, here's my entire population, and I'm going to randomly choose two things out of there, and I want to know, how can I go about getting two purple people? You know, how would that happen in order for me to get two purple people? And then tomorrow we add to it the probability parts. So in other words, we say, hey, what's the probability then that from this population I choose two of the purple people out of it? So that's where these balls and urn problems, what they actually represent when we're talking about the statistics behind it. But right now, let's just keep it nice and simple. And let's just talk about how can we. So we're going to describe using words how we can choose two purple marbles or balls or whatever from within this urn. So, well, if I'm going to choose two balls out and I want to get two purples, then on the first one I have to get a purple. So I'm just going to write that down. Purple. And, now you hear me say that word and in there? That's really important. So the words and or when you're doing your homework, I want you to make sure that you are using those words, that you write down the word and. Don't just tell me 2 purples. I want to know how you're getting those 2 purples. So in other words, you're doing a purple and a purple. A purple and a purple. That's how we can get 2 purples from this ball. Now that seems really silly, right? But being able to put it into words like this is going to help us when we're trying to figure out the probability of it later. So there's our first one. Now I'm going to take that same type of situation, and this time I want to know how. Again, I'm just asking this question of how. I want you just to describe it for now. How can we choose no purples? So I don't want to get a purple this time. I want to know how I can go about it so that I don't get a purple. Yes, Zoe, I'll work on that. So so how are we going to do these no purples? Well, first I could get, instead on my first one I could get a red, and on the second one I could get a red. Or on the first one I could get a red, and on the second one I could get a black. Or, so that I'm getting no purples. So they're going to be, I could write that down using words. I could get a red on my first one. And, again, here's that conjunction, that and in there that's super important. And a red. Or I could get a black and a red. Or, so I could get a black and a red, or maybe I get the red one first and then a black one. But I'm going to make this easier for you instead. Instead, what I'm going to do is, instead of going through each one of them, since I don't want a purple, let's just call the other ones not purple. Let's split these up into purples and not purples, and just call those over there not purples. So then, using words, instead of going through each one of these little scenarios, by breaking it up into 2 things, I can just say, well, I don't want a purple, so not purple, and not purple. Or, here we've got not purple. Oh wait, not or, that's just it. That's it. So, no matter which color it was, it's red or it's black or it's whatever, those are not purples. They're just not purple. That's a lot easier to do than saying red and black or black and red. It's just, they're not purples. So being able to put that in words again is really, really important. So that's how we could choose no purples. All right, let's do one more of these with this urn, and let's do exactly 1 purple. Let's do exactly 1 purple there. So now, when I talk about exactly 1 purple, now I could get, if I'm going to pull it out, I could on the very first draw get that purple. I could get the purple on the first one. So I could get a purple on the first one. But I'm drawing out 2 balls, so I have to have a second thing that happens. So purple and something else. Well, I just want 1 purple. If I get another purple, then I didn't get exactly 1 purple. I've got to get a different color. So we're going to say a purple and not a purple. So again, that important word of and, not a purple. But maybe I don't get the purple one on the first try. Maybe instead I get not a purple on the first try. So, or, there's that conjunction in there, because there's another way to do this. Or I could get not a purple first and then get the purple. Okay, so this is the whole idea of that very first homework that you're doing, is all I want you to do is describe in words how you could go about getting getting those different things that are happening in the scenarios. And also notice that sometimes there's an easier way to do it, and just dividing it up into two different categories like purple and not purple might be easier than saying, well, I could get a red and a red, or a red and a black, or a whatever. So like Tiny Tim in the homework, Tiny Tim's got knives and toys. Well, that's nice and simple because it's already divided up into two groups. But some of the other ones aren't divided up into two groups, so you kind of have to work through or think about what two groups could I do. Hey, yeah, that was the whole thing, Mr. Simpson. You're right on my wavelength there, because notice that I could get 0 purples out of this urn, or I could get 1 purple out of this urn, or I could get 2 purples out of this urn. Now, how can I get at least 1 purple? So again, I'm asking how. How can we get at least 1 purple? That's what we're asking, okay? So we're going to just describe in words how we could get at least 1 purple. Well, at least, this is an important little phrase here, that at least. Let's think about what it means to be at least. If my doctor says I need to take at least, or drink at least 2 bottles of water a day, then my doctor is telling me that I need to drink 2 bottles of water or more. You know, I can't just drink, I could drink 2, or I could drink 3 or 4 or 5. So, my doctor says drink at least 1 bottle of water every day. At least 1, get some water in you. So, well, that means I can drink 1 bottle of water, or I could drink 2 bottles of water, or 3 bottles of water, or 4 bottles of water. I have to drink 1 or more of that. So this at least means 1 or more. So again, being able to put it into words is super important. So yeah, at least the minimum, at least that. And if you guys are going to be nurses, this is really important. If the doctor tells you to give your patient at least, he needs to at least walk down the hall a certain number of feet, then you need to make sure that you're doing that patient's walking that far or further, or whatever it is that they're asking you to do. At least use 1 bandage. Well, then you should be using 1 bandage or more on them. So, well, notice here I've got 1 or more. We're putting it into words. And so when we're trying to find the probability of it, that's going to be super helpful in order for us to do that. So it's going to be that 1, or in this case, the only other number that's bigger than 1 is 2, because we're only drawing out 2 from the urn. So it's going to be 1 or 2. Well, for 1, we had multiple different ways of getting that. So again, using my words, I'm going to use these words, or we could do it this way. So we could get, in order to get 1, we could do a purple and not a purple, or we could do not a purple and a purple, or we could do a purple and a purple. So there are 3 different ways that I can get at least 1 purple. And again, putting it in words, make sure you're using these conjunctions in there. So if you've already turned in that first homework and you didn't do that, you didn't go through and tell me with those conjunctions in there, I'm going to type you a comment on Dropbox. I'm going to say, hey, make sure you're using the conjunctions. This is what I mean. And you have a chance to upload it again. because I'm not gonna grade them officially until Sunday. So I may make some comments on there, pay attention to those comments, and then go in and make the corrections and re-upload it so that you can get full credit for it. Okay. All right. So there it is, nice at least. Well, what if I did this? Let's take that same thing, and now let me ask you, what about at most? What in the world does that mean? So we could do 0 or 1. So notice how we've got that conjunction in there. So that's what we want, is that 0 or 1. Those are the numbers that we could do. So if I can drink at most 1 Diet Dr. Pepper a day, then I could drink 1, or the doctor would really prefer me have 0, right? So at most 1 means 0 or 1. So again, if I'm putting this into, if I'm going to describe this with words, then I would say, well, it's the ways I can do 0 or the ways I can do 1. So it's the ones would be purple and not purple, or not purple and purple, or for 0 is not purple and not purple. So see how you have to be able to think of it this way and then go back and be able to put each one of those then into words, which ones it is. Now let's do another example here. So let's move away from our purples for a minute, and let's talk about doing another situation, still with this balls in an urn thing. These marbles in a jar are just such a good representation of us sampling from the entire population. And when we're talking about the probability here, we're just talking about, what is the probability that we get a certain sample from this large population? Is this an unusual sample, or is that a sample that we expect to get? So those are the types of things that are happening. Okay, so now I want to know, if I pull a blue, I want to know how can I choose a blue and then a red. So again, putting it into words, that's the whole idea. Is I want you just to picture yourself. From this jar, I'm going to pour out 2 balls. If I want to get a blue and then a red, what do I have to get first? I have to get that blue first, right? In order to get a blue and then a red, I have to get the blue first. And then again, I'm pouring out 2 balls. Well, then what do I have to get second? Well, I have and a red. I mean, it basically told me in the scenario, a blue and a red. So I'm just putting it in those words, and again using that conjunction. And that's the only way I can go about getting a blue and then a red. I have to get it in that order. What about here? I'm going to change up the words just a little bit, just tiny bit, changing up the words. So what about if I got a blue and a red in no particular order? No particular order. Now I want to know how can I go about getting that blue and a red? So this time the order that I get them in doesn't matter. Well, up here we got a blue and a red, so we can do it that same way. A blue and a red. But the order here doesn't matter. So I could also get it the red first and then get the blue. So I'm going to use that conjunction. Again, these conjunctions in here are going to be really important. That or I could get a red and a blue. So there are two different ways that I could pull a blue and a red out of this particular jar. I could get the blue first, or I could get the red first. So knowing whether or not the order matters is kind of important on how many different ways I can do it. All right, same idea, same urn. How can I get the two of the same color? So now I want to get two of the same color. All right, so how can I get two of the same color? Well, let's look up here and see, where do I have two of the same color? Now, all of a sudden, it is kind of important that we know whether or not we're putting the balls back in the jar or not. So, you know, if I'm putting, I know that I can get a purple and a purple because there are two purples. I know I can get a red and a red because there are two reds. This black, though, there's only one more black in there. So if I'm taking out two, I can't get two blacks. But if I'm taking out a black and then putting it back in before I then take it back out again, then I could get two blacks. So we could, if it's with replacement, in other words, if I'm taking these marbles and taking them out and then putting them back in, I could get two blacks. But if I'm not putting them back in each time, if I'm just taking them out and leaving them out, then I can't get two blacks. So let's start by doing it with replacement. In other words, I'm going to take out a marble, look at it, and then put it back in the population, and then take it out again and look at it. Well, in that case, there are three different colors. I could get a purple. I was calling them blues earlier. Oh well. A purple and a purple. Or my purples and my blues are interchangeable. They're the same color, obviously. Or a red and a red. Or I could get that black and black. So there are three different ways I could do it. But if I'm doing it without replacement, that same thing, two colors, then all of a sudden my number of ways that I do it changes. So this is where just being able to wrap your mind around what it is that's happening in this scenario is really important. It's like, can I just picture what's happening? That I'm taking out two balls and not replacing them. Or I'm taking out a ball, looking at it and putting it back in. And then being able to verbalize or put into words how you can go about it. We can't add the numbers to it. We can't do the probability until we get this part down first. How can I do it without replacement? Well, I can still get the purple and the purple. Or I could get the red and the red. But I can't get the black and the black because there aren't two blacks in there for me to get. Okay. So let's do one more with the urn, and then we're going to change it up a little bit. Let's do, how about we do two different colors. So remember earlier I said let's just divide it into two groups, you know, purples and not purples, or, you know, it made it nice and simple. Well, in this case, when I'm talking about two different colors, all of a sudden I can't divide it into two different groups because my purples and my reds and my blacks are all three different things. So I can't just split it up into two different groups, unfortunately. So I have to go through all the different possibilities. So being able to figure out when we can split it into two groups and when we can't split it into two groups is going to be important, especially for next week as we learn about something called binomial and hypergeometric, where we have to be able to split them into two groups in order to be able to solve them. So here, though, we don't have, we can't just split it into two groups. I have to split it into, use each one. So to get two different colors, let's think about that in words, how I can get two different colors. And hopefully you're starting to do that. You're like already, you know, writing down or thinking about what are the different ways I could get two colors. So let's pretend I pull out a purple one on the first one. Then on the second one, to get a different color, I have to either get the red or the black. So I'm going to do one way first. So purple and red is one way to do it. Or if I get the purple one first, I could get the black one second. So it just depends, you know, those are both two different colors. I could get this and that, or I could get this and that. Or maybe I don't get the purple one first. Maybe instead I get this red one first. Well, if I get the red one first, then I could get the purple one second. Or I could get that red one and then get the black one second. So there's another situation. Or maybe I pull the black one out first. Well, if I pull the black one out first, then I could get either the purple one second, or I could get the red one second. So again, being able to put it into these words is exactly what I want you to think about on that first bit of homework, and be able to write it down and make sure on every one of your problems, you should at least have the word "and" in there, unless we're just choosing one thing out of it. I mean, there should be at least that word "and." And then on many of them, you're going to have the word "or" also. So if there's more than one way to do something, you're going to have that "or" in there as well. Let's go fishing. So let me draw you some fish up here. In our lake, we're going to have some fish. First, let's start with, I don't know, how about 4 redfish? 1, 2, 3, 4 redfish. And then let's do bluefish. Redfish, bluefish, 1 fish, 2 fish, redfish, bluefish. That's my former life, is, you know, Dr. Seuss. And then let's use a color you can't really see. How about an orange? We'll do 1 orange fish. I don't know if you can see him or not. There's an orange fish. And then I need 1 more. How about a rainbow? How about we got a fish that's kind of rainbowy? He's part blue. And maybe 2 of those. Part blue, part purple, and part red, and part orange. Aren't my fish beautiful? See, my kindergartners would tell me what a great artist I was. So we got 2 rainbow fish there. That's how that's supposed to work. I was supposed to tell me, wow, you're such a great artist, Ms. Simpson. My praise is what I need. Okay, so here's what we're going to do. We're going to catch 3 of these fish. Let's catch 3 of them. And I want to know, I know, right? Adults are a lot more honest than kindergartners are. They always say kindergartners are honest, but adults are much more honest. Okay, so now we're going to catch 3, and I want to know what's the way that I can catch, or how can I get 3 redfish? This is a lot harder because normally y'all would be like, and you would be telling me how to do it. Instead, I'm like imagining. I'm really using my imagination. I hear y'all. You are yelling out right now that you could get a red and a red and a red. So the way we have to get 3 red fish is first we have to get a red, and then the second one we catch has to be a red, and then the third one we catch has to be a red. That was nice and simple. Let's make it a little bit difficult, more difficult. What about, how can I get 2 red? I bet. I always sound crazy though. That's just me. Okay, so now I want to know how I can just get 2, or exactly, let's say exactly 2. Let's add that exactly in there so that we are exact. So now we got to think about the exactly 2 red. So the question here is, can we, like we did before, split it up into 2 different groups? In other words, do I have to do like I did on that last one with the different colors, where I talk about all, the rainbow and the orange and the blue and the red? Or can I do 2 different colors here? Or 2 different groups? Can I just split it up? Since I'm just looking for 2 reds, then I could definitely do it that way, Bo. I could split it up and say, I get a blue and a red, or a blue, a red and a blue and a red, but man, in that case you just did the blues, right? And then you also have this idea of also doing the oranges and also doing the rainbows. So that is a good start on that, but there sure are going to be a bunch of them, right? So when I start getting a whole lot of those different potentials or possibilities, I start thinking to myself, is there a way just to split it up into 2 different groups? Like maybe instead we were able to split it up into red and not red. And then that way it just makes it oh good, splits it up. Exactly. You got it. So there, we just want to say, so everywhere you said blue, Bo, what I'm going to do is just switch it into a not red. So that it's that same idea. I could get or everywhere, yeah, that's right. So, we could get that red first and a red first. And instead of saying blue, we could just say, and not red. But you had exactly the right idea. Wait, he did blue first the first time, so we'd say not red, and red, and red. That was exactly the right idea. Or, which one did I forget? Red and not red. How about the middle one? Red and, I need to put that in the middle, right? So red and not red and red. So now we've done it at the end, we did it at the beginning, we did it in the middle. And notice that not red includes our blue, it includes the rainbow, it includes the orange, it includes all of our guys. So being able to split it up and knowing, okay, this is when I can split it up into 2 groups and this is when I don't split it up into 2 groups is kind of important. All right, now let's see if you can do 1 red, exactly 1 red. Got it. So one way to do it is to do not red and not red and red. So that I end up with only 1 red. Or that red could move around, right? He could be, let's just move him into the middle. So we've got not red and not red, or we can move him all the way up front, red and not red and not red. Now, do you see where this is going again? Remember that distribution that we made earlier, where we talked about the different numbers that we could get? So if I'm catching 3 fish, here I caught 3 red fish, here I caught exactly 2 red fish, there I caught exactly 1 red fish. The only thing that's missing from this is for me to catch, good, no red fish. Or you could say 0, no, or 0 red fish. So how would I go about not catching a red fish? Good, I could get I'd have to get a not red and a not red and a not red. So all our different outcomes are possible outcomes. You know, if I get ready to make my distribution table, or my probability distribution table, the number of reds I catch is my x. So this is the number of red fish that I can catch. Well, I can catch 0 of them, or I can catch 1 of them, or I can catch 2 of them, or I could catch 3 of them. So that's my variable there. Then, you know, if I were to go out and do trials, I could do the frequency, or tomorrow we'll talk a little bit more about the probabilities, and we'll put the probabilities in there for each of those. Then also, this kind of helps us to understand this idea, helps us when we get ready to do those things where we're talking about the at least and at most. So if I said I needed to catch at least 1 fish, 1 red fish, I want at least 1 red fish, well then I have to get 1 or more. So I would be looking at all the ways to get 1, 2, or 3. So to get at least 1 fish, 1 red fish, I could do it this way, or these ways, or these ways. That's a bunch of different ways that I could get at least 1. So this is at least 1 red fish. Is all 3 of those put together. Now notice on this, who's missing? The 0's not included in that. So the 0, though, makes up the rest of the set. That 0 is the complement to at least 1 red fish. So this one, the 0 is the complement to at least 1. He is the complement because he's not included in the set and yet makes up the whole set if you add him to it. So sometimes, we're going to find out later, that sometimes when we're looking at least, maybe what we want to look at is this complement, because it might make it easier just to find the complement and subtract that off. So tomorrow when we talk about the probability, we'll use that complement to help us. Then what about at most 1? So let's think about at most 1. So again, my doctor says I can have at most 1 Diet Dr. Pepper. I would drink 1 Diet Dr. Pepper or less. So at most means that or less. So at most 1, 1 or 0 makes up at most 1. So if I were looking for all the different ways I could do at most 1, then I would do the 0 or the 1. I think earlier I pointed at the 0 and I meant the 3, or whatever. Okay, so 0 or 1, those are the at most 1. Notice here the complement of that is 2 and 3. So these 2 and 3 are not part of that set. So the complement of at most 1 are these two. The complement of that are the 2 and the 3. So the complement makes up the whole set. And this kind of helps us to see maybe using the complement here wouldn't be as good. Whereas on the at least one, using the complement would be, easier because I'm just dealing with 0. So knowing when to use the complement and when not to use the complement is another thing that we're going to be looking at. And being able to kind of visualize what we're doing is important. Okay, so Christopher Walken just decides on a step, some random step. So we go down right here. He picked some random step to start on. And today he rolled the dice and he ended up on that third one down. And then what he does is he just randomly walks up and down the steps, just randomly, takes steps up and takes steps down, and he does that until he either hits the well or he hits the landing, one or the other. Okay, so I want to know how can he finish his exercise? How can he finish his workout in just 3 steps? What would he have to do in order to finish in just 3 steps? So let's look and see. Can he make it to the well in 3 steps? Because 1, 2, 3. No, he doesn't make it to the well, does he? So let's try the landing. Can he make it to the landing in 3 steps? 1, 2, 3. Oh yes, he can. So in order for him to make it to the landing in just 3 steps, he would have to go up and up and up. So I'm going to write that in words. Maybe I use symbols. Up and, this is really important, up and up. So he's got to go up and up and up in order to make it there to the landing. All right. Now, what about if he wanted to finish in just 4 steps? And exactly, he wants to today for his workout take exactly 4 steps. How can he take exactly 4 steps and end his workout in exactly 4 steps? And let's see if he goes down to the well. Does he make it in 4? 1, 2, 3, 4. So if he just goes down 4, perfect. Down and down and down and down. Now the question is, can he make it to the landing in 4? Like, if he goes up and up, well, if he goes 3, he's done. So we can't go up, up, up. But can he go up, up, down, up? Oh no, that didn't quite, he's going to have to go 5 steps in order to go to the landing. So, and if he goes down 1, then he goes down, 1, 2, 3, 4. Oh, he didn't finish there either. So going to the landing, he can't quite get there in 4 steps. All right, what about if he wants to do it in exactly 5 steps? So in exactly 5 steps, where would he end up? Can he get down to the well in exactly 5 steps? So let's try this. Let's see, 5 steps down. He goes 1, 2, 3. Oh, can't do the 4. 4. Oh no, he doesn't quite make it there. Okay, so let's try going up first before going down. He goes 1, 2, 3, 4. Oh no, that didn't work. So he can't make it to the well in exactly 5 steps. What about the landing? Can he get to the landing in exactly 5 steps? Let's try that. So he goes 1, 2, 3, 4, 5. Oh, he made it to the landing. So how did he do that? Well, he went up, up, down, up, up. So up and down and up 2, 3, 4, 5. Oh yeah, that works. And up. Is there another way to do it? Can he go down first? Let's see if he goes down first. So he goes down. 1, 2, 3, 4, 5. Oh, so he can go down first. That would work too, right? 1 and up and up and up and up. Now I left out a conjunction there. What word did I leave out there that's really important? Yay, the word or. I can do it this way, or I can do it that way. And when we're finding the probabilities, that or is going to be super important, that we need to be able to find that or in there. So being able to use those words and being able to do it in with the conjunctions is super important. And then, is that all of them? Let's see if he goes down 2 steps. 1, 2, 3, 4, 5. Oh, we didn't make it. Up and down and up and up and up. Didn't we do that one? Up and down. Let's try it. Up and down. And up and up and up. Oh, that works too. Look, there's the other one. That's why I have my class normally, is they're supposed to tell me that. Look, so there's another one. So it's up and down and up and up and up. Thanks, Mr. Simpson. So we put the down arrow here. We put the down arrow in front, and we put the down arrow in the middle. If I go one more down, we said we can't put it here, so we definitely needed one more there. And today what we're going to do is take what we did yesterday and just add the numbers to it. So yesterday we did the classical probability using the words, and today we're going to add the probability or the numbers with it. So the first step in solving all of these classical probability problems is going to be first to just get all probability problems, just get your mind wrapped around it. What is it saying? What is the scenario? And then once you have your mind wrapped around it, then it makes finding the probability a lot easier, much, much easier. So yesterday we had this urn with some balls in it, and we talked about how this, represents our population of people or whatever things, and then we just sample from it. So this is a good way to show that sampling from a population. And then what's the probability that I get a certain item? Now yesterday I had 1 black, 2 purples, 2 reds, and a black. Okay, cool. Alright, so I want to use the same ones as yesterday because we already went through the process of doing the words on it. So then yesterday, I think we were at first doing draw 2 from the urn, and then we wanted to know what's the probability that we draw 2 purples. So we're going to draw 2 purples, and the way we did it was we said we were going to draw a purple and a purple. So we did these words yesterday, and our job today is just to put the probability with it. So instead of how can I draw 2 purples, I'm going to ask today, the question is going to be what is the probability, this black's no good, what is the probability I draw 2 purples? What is probability we draw 2 purples? So yesterday we just asked how can we draw 2 purples, and today we're going to ask what's the probability of it. Okay, so to get 2 purples, you told me yesterday it was purple and purple. So now I'm going to look at each piece of it. And I kind of need a little bit more for this experiment, because I need to know, when we draw them, are we going to take them out of the population and leave them out? Or once we look at the ball, are we going to put it back in before we draw out the second one? Because those 2 are going to give us 2 different probabilities. So let's start with 2 draws with replacement. In other words, I'm going to put it back in. I'm going to take out one of my balls, look at it, and then I'm going to put it back in to look at it. And good. What is the probability I have to draw a purple? You're exactly right. It doesn't matter if it's with replacement or without a replacement on the first draw. It doesn't matter. Because you're exactly right. There are 2 purples out of a total of 5 marbles. Okay, so I take it out, I look at it, I go, hey, it's purple. I put it back in. What's the probability then on the second one that I get a purple? Good job, y'all have already got it. So that's also 2/5. Because now it's still two purples out of the 5. And the and then tells me just to multiply. Now, when I'm not adding, I like to simplify first. So if we can simplify in this step, we would simplify at this point. But there, the factors on tops are both 2s and both 5s on bottom. They don't go in, so we can't simplify it in any way. So we just multiply straight across. 2 times 2 is 4, and 5 times 5 is 25. So if I were to do this experiment 25 times, in other words, if I were to take out a ball, look at it, put it back in, take out another ball, look at it, I would expect 4, if I did that 25 times, I would expect 4 of those times to get a purple and a purple, to get 2 purples. Okay, now what about if we did this exact same thing, but we did it without replacement? So without replacement, purple and purple. Well, on the first one, what would my probability be? Still 2/5, right? We still got 2/5 because it's 2 out of the 5. But now it's without replacement. So I took this purple out and it's in my hand. That purple is now in my hand. So now what's the probability that I get that second purple? So now there's only, how many purples in there? 1 out of a total of 4. So notice it changed on that second one. It was dependent upon the first one. Once we drew one out, then the second one was dependent upon that first one. That and we're still multiplying though. Again, when I'm not having to add anything, if I can simplify ahead of time, I'm going to simplify ahead of time. So that this 2 goes into that 4. Because remember, we just multiply straight across, so that's going to be on top regardless. And so now I just have a 1 on top, and 5 times 2 makes 10. So there's a 1 out of 10 chance. In that case, if I did the experiment where I poured out 10 balls, if I did the experiment 10 times, only once would I expect to get 2 purples. Let's do no purples. Oh, maybe I should hold on to these for a second. The probability, I'm going to make myself a probability distribution table for both with and without replacement. So on that first one, we were drawing 2 purples, and the probability was 4 out of 25. The probability that we got 2 was 4 out of 25. Without, though, when we got 2 purples, the probability was 1/10. So we started this yesterday, making a table, and we talked about the random variable was the number of purples that come out. So now all I'm going to do today is add that probability to it. So if I did the experiment 25 times, I would expect the frequency of them to be 4, where I got 2 purples. And here, if I did it without replacement, if I did the experiment 10 times, then I would expect to get 2 purples, 1. My frequency there would be 1. Okay, so now back to 0 purples. And we'll keep this without replacement. So 0 purples again. And again, you told me yesterday, we looked at the words and we said it would be easier just to say not purple and not purple. Remember we went through all the different things and they were like, oh, that's too complicated. Let's just do not purple and not purple. Perfect. Y'all got these words. So now I want to know what's the probability that I don't get a purple on that first one. So, you know, out of there's 3 out of a total of 5. So my probability is 3/5. And tells me to multiply. Now I'm taking it out, and this one it's with replacement. So I got one of these 3, not a purple, looked at it, put it back in. Now I'm going to draw again. So what's the probability on the second time? It's still that same 3/5. Good job. So again, I'm not adding, I'm just multiplying here. So they can't simplify beforehand. 3 times 3 is 9, and 5 times 5 is 25. So the probability that I get 0 purples, so this is the number of purples I can get, is 9 out of 25. So this is how a probability distribution table works. Then what about for with replacement? On the first one, once we have the words down, it makes it nice and easy, because now all we're doing is just, I'll explain about the 3/5. So the not purple and not purple, once we have those words down, it just makes it so much easier to find the probability. So let me do a better job of explaining that. So there's not purple. Good, Bo, that does explain it. There's not purple. Well, there's 3 of them that are not purple. 1, 2, 3. Out of a total of 5 balls in there. And so that's why the probability is 3/5. Perfect. And then once I take one out, you're right, there's only 2 not purples left in there out of a total of 4. So there's 2 out of a total of 4 left in there. That and with the probability, you know, tells me that rule tells me I'm multiplying there. Again, when I multiply, I like to be able to simplify first. And so I'm going to simplify, and you're right, I'm just subtracting 1 from here because I took out one of the not purples and I took out one of the full population, so it just leaves me with 2/4. So now I like to simplify first if I can. This 2/4 is the same as 1/2. Now I can multiply straight across, and I've got 3/10. So again, out of 10 different experiments here, 3 of them I would expect to get 0 purples, or not get a purple. So 0 is 3/10. That's the probability that I get 0 purples. Now we did 0 purples, we did 2 purples, but we could also get 1 purple. So let's do that next. So let's get 1 purple. And again, we did this with words yesterday. So I'm going to make it go a little faster today, because you told me yesterday that we could get a purple and a not purple, because we could draw the purple one on the first one and then draw a not a purple one on the second draw. Or we could do the not purple first and then do the purple. So being able to put it into words is going to be really helpful, because once you have it into words, now we're just putting those probabilities with it. So that's super important to be able to do. But we did that yesterday. So the probability of a purple on the first draw is 2 out of the total of 5. So 2 purples out of a total of 5. And the probability of not a purple, well, I put it back in. Remember, I take it out, but then with replacement, I'm putting it back in. So the probability of not a purple, well, it's 3 out of the 5. Remind me, what is the or? Tell me. Good. I'm going to add there. And then, so that's one way to get a purple first, is do a purple and then a not purple. Another way to do it is to do the not purple first, So one of these 3 out of a total of 5. And so once I've gotten it, I put it back in, so there's still 5 in there because it was with replacement. And then there's 2 purples inside, so it's 2 out of 5. Y'all are good. Okay, so now notice this time I'm adding in here. Remember, when we add fractions, we have to have a common denominator. And since we have to have a common denominator, I don't want to simplify until the very end. So anytime I'm adding, I'm going to wait to simplify till the end. So I've got on top, I'm going to multiply these. 2 times 3 is 6. 5 times 5 is 25. Plus 3 times 2 is 6. 5 times 5 is 25. Notice that these guys are the same. Do you see how the numerator here is the same and the numerator there is the same and my denominators are the same? So I ended up with the same probability even though the order was different. So really I just had to find out the 625 and then I say how many different ways are there? Well, there was 2 different ways to do it. So I could add them together like this, or I could just multiply. I could go this 2 different ways and multiply 6/25 by 2 to get that 12/25. Okay, so there's with replacement, with 1, I've got 12/25. So here's the probability distribution. I can't get more than 2 because I'm only drawing 2 out of there. So I could get 0 purples, 1 purple, or 2 purples. And then this is the probability of each one of those. So with replacement, this is my probability distribution table. And if I've done it correctly, if these probabilities are right, then this plus this should make the whole set. You know, to get 0 marbles or 1 marble or 2 of the purple marbles, those are the only ways, you know, if I say, what's the probability that I get 0 purple, 1 purple, or 2 purples? Well, that should be 100%. So, you know, 100% of the time I should get either 0, 1, or 2. Good, it should add up to be 25 over 25. Or 1, does it? Let's see. That's 21 plus 4. Sure enough, it equals that 1. So if I've done all my probabilities correctly, this should add up to be one whole full thing. Okay, so now let's do it for without replacement. And how does that change things when I do without replacement? So still 1 purple. Still the same setup, purple and not purple, or not purple and purple. So now the probability without replacement, the probability that I get a purple on the first draw, well, it's still 2 out of 5. But now I've got this purple in my hand. So what's the probability? I should get this purple instead. I got this purple in my hand. So what's the probability that I don't get a purple on the second one? Well, there's only 4 marbles left, and 3 of them are not purple. So it's 3 out of the 4. The and tells me to multiply, the or I'm adding. Okay, so now what about a not purple on the first draw? Well, out of the 5 marbles, 3 of them are not purple. But then, once I take one of them out, it leaves me with only 4, and I'm not replacing it. It leaves me with 4 marbles, and 2 of them are purple. That and lets me to multiply. Okay, again, I could simplify, right? And if I can simplify in both places, then maybe I want to do it. But I want to make sure when I'm adding that I have a common denominator in the end. So maybe I just wait to simplify until the very end. So anytime I'm adding, a lot of times I'll wait until the end to simplify. So I'm just going to go ahead and multiply. 2 times 3 is 6, and 5 times 4 is 20. So I've got 6/20ths on both of those. Notice again that the probability was the same. That order didn't matter when it came to finding that probability. this one and that one. Well, I just needed to know that there were two different ways to do that. This is going to be important next week when we talk about binomial and hypergeometric. So now I add across and I get 12/20ths, but I can simplify that. 4 goes into the top and into the bottom. So, you know, I can divide by a fancy 1 to get 3/5. So the probability that I get 1 marble is 3 out of 5 times. Now, these guys should all add up to be 1, because I can either get 0, 1, or 2. So my probabilities should all add up to be 1. On this fraction, remember that I have to have common denominator. So this is the same as 6/10. So let's see if it really does add up to be one full thing. 3 plus 6 makes 9, plus 1 makes 10. So we got 10/10, which is equal to 1. So that just lets me know that my, hopefully I did them all right there. And it lets me know that, yeah, they at least add up to 1, which is what it's supposed to add up to. Okay, so this is a probability distribution table. That's what this is. It just shows the possible outcomes. So there's my sample space is 0, 1, and 2. But they're not all equally likely. It is more likely that I'm going to get 1 purple than I get 2 purples. So, you know, if I were doing a symmetric sample space, I would have to do that 0 9 times, the 1 12 times, and the 2 4 times to make it a symmetric sample space. So we have purple and then red. And let's first do it with replacement. And we did the words yesterday, and we said, well, the only way I can get a purple and then a red is I have to get the purple first and then a red. So that made it nice and simple. And if I'm doing it with replacement, well, my purple we've looked at over and over again now is 2 out of the 5. And tells me I'm going to multiply. The probability I get a red, well, in this one I'm putting it back in. I'm replacing it. So once I put it back in, it's 2 out of the 5 again for that red, because there's 2 reds. So now I'm simply multiplying, so I just do 2 times 2 is 4, and 5 times 5 is 25. By the way, I'm done with this. This was just for purples. And this particular example is one of the ways to do that. But it's not all the ways to do that, because I could also get a purple and a black. We said purple and not purple because it just made it easier. So I'm going to get rid of this probability distribution so we don't get confused with what that is. All right, now without replacement for the same thing, purple and then red is still purple and red. And the only way it changes is on the first one, the purple is still 2 out of 5 because there's 2 out of 5 in there. And it's still multiplication. The only way it changes is now I have one of those purples in my hand. I'm not putting it back in. So it leaves me with 1 out of 4. I'm not going to do any adding, so then I'm going to reduce. So 2 goes into 4 2 times, so I will have it end up with 1/10. Oh, you're right. There are 2. Good catch there, Tish, because there are 2 reds in there. You're exactly right. Good catch, good catch. So that I still end up with, instead it's 2/10 or 1/5. Because while our purples went down, our reds didn't, did they? So it should have stayed 2 instead of the, you're right, exactly. Because it's half a chance that I get that red one. Good catch. Good catch. Now, I'm going to do this same thing, except I'm going to remove one word. Instead of saying and then red, I'm just going to say a purple and a red. Not purple and then red, I'm just going to say a purple and red. So notice all I'm doing is taking off that one word. That's it. Okay, now I'm stealing away this word. And then. And we kind of looked at that yesterday. So what that means is I've got a purple and a red, but I could also do or in the other order. So by taking away that then, well then I could do it either way. I could do it this way or I could do it that way. And the same thing's going to be true here. The minute I take away that and then, the order I could do it either way. I could get my purple first and then my red, or I could get my red first and then my purple. But notice, this probability is the same. I just have to do it twice. Because now I've got that or in there, and I find the probability of the red first, and then I put it back in, so the probability of the purple is still the same. So my probability for each one of these stays the same every time, regardless. Excuse me, this probability for purple, because I'm putting it back in, I'm replacing it back in every time, that probability stays the same each time. Whereas over here, the probability changed dependent upon this first one. So that or, so the probability of my red this time is 2 out of 5. Notice that these guys are different. They're not the same probability. And the purple is now, well, I only have 4 marbles left, but there are still 2 purples in there. So while these probabilities are different, if you look at the full thing, there's still a 5 on bottom and a 4 on bottom, a 2 on top and a 2 on top. So while each individual probability changed, the probability of getting a red and a purple is the same as getting a purple and a red. So I'm going to go ahead and do that simplification where I get 1/2, because then I'll end up with 10 on both of them, so I can add it together. A lot of times I'm careful to wait to simplify, because when I'm adding, I want to make sure I have common denominators. So, and I could even simplify again to do this 2 and that 2. But since their probability is going to be the same, I should end up with the same denominator. So maybe we simplify again, make that a 1, make this a 1. So we should just end up with 1/5 plus 1/5, which equals 2/5. So the probability there is going to equal 2/5. All right. Now, yesterday we did 2 of the same colors. So let's look at that a minute. So 2 of the same colors. And so if I'm putting it back in, yesterday we looked at it and said I could get a purple and a purple, or I could get the red and the red, or I could get the black and the black. Now we said that we could do that yesterday, black and black, because I take it out, I look at it, but then I put it back in. So I can get black and black with replacement. But when I do without replacement, and I do 2 of the same colors, so I can still get a purple and a purple, because I can take out both of these purples. I can still get or a red and a red, because I take out both of these reds. But think about the black for a minute. If I take out the black, can I on the second draw get another black? So yeah, that's all I can get, exactly, is purple and purple or red and red. That's it. I can't get the black and the black. So without replacement, my probability is going to be a little different. So here I have a purple and a purple. The probability of the purple on the first one is 2/5. And the probability on the second one is 2/5. Or the probability of the red is 2/5. And because I'm putting it back in, the probability is still 2/5. The probability of a black is 1/5. And the probability of the back is 1/5 because there's 1 out of the 5. I take it out, put it back in, it's still 1 out of the 5. Now, nothing simplifies here, but you can see how if one of them did simplify, you might not want to simplify first because of these additions. I need the common denominator to be the same. And so right now, it's going to have a common denominator. But if I were to simplify one of them somewhere, then they wouldn't have a common denominator. So anytime I'm adding, I like to wait till the end to simplify. Okay, I'm going to go ahead and multiply. 2 times 2 is 4, 5 times 5 is 25. Plus 2 times 2 is 4, 5 times 5 is 25. Plus 1 times 1 is 1, 5 times 5 is 25. Now I add them together. My numerators, remember, you just keep your denominator. Add your numerators. 4 plus 4 is 8, plus 1 is 9. So there's 9 out of 25 chance. If I did this experiment 25 times, I would expect 9 of those times for me to get the same color. Over here, I've got 2/5 for my first one, 2 out of the 5. But now I've got this purple in my hand, so I just have 1 out of the 4 for the probability for the second one. Or the probability of getting a red on the first one is still 2/5. But once I take out one of them, I'm just left with 1 out of 4. So, and 1 out of 4. Since I'm adding, I'm going to wait to multiply, and it is the same as 9. I'm going to wait to multiply until, simplify until the very end since I'm adding. So I've got 2 out of 20. 2 times 1 is 2, 5 times 4 is 20, plus 2 out of 20. Add those together and I get 4 out of 20. Or that's 4 goes into 20, 1/5. That simplifies down to 1/5. All right, so there it is with 2 same colors. And you can see how this is different depending on if I've got with replacement or without replacement. I have to be able to think through the scenario and go, wait a minute, I can't get 2 of the blacks. I can only get 2 purples and 2 reds. All right, then we did yesterday 2 different colors. We did 2 different colors. And I think we talked about yesterday that if you get 2 different colors, then that's the complement of getting 2 of the same. You know, if I don't get 2 of the same colors, then I'm getting 2 different colors. So those make up the full set. So I can just take this and say, hey, look, this is the complement of 2 different colors. So for to do 2 different colors, I can use this. Remember, to find the complement, you do 1 minus. So 1 minus 9 over 25. Make that into a common denominator, so 25 over 25 minus 9 over 25 equals 16 over 25. So if we think about the probability distribution for this, my x, my random variable here is, or my sample space is to the same color or to different colors. You know, that's the sample space. And those two should make up the whole thing. I either get same or I get different. And my probability for two of the same is 9 out of 25. And the probability for two different is 16 out of 25. These guys are complements of one another. Over here, two different, I can do the same thing. They're complements, so I can just subtract 1 minus the probability I got there. I'm going to turn that 1 into 5s. So 5 out of 5, not the complement meaning, yes, the complement meaning the opposite. You're exactly right, Imani. Not like, I'm so beautiful today. Yeah, when I tell y'all are great students, you work so hard, you're fabulous. Those are compliments, but this is a compliment with an E rather than a compliment with an I. So I've got 5 over 5 minus 1 over 5. So this is 4/5. These two make up the whole set. So looking for the complement sometimes can help you, because if I were going to go through and do all the ones that were different, we kind of talked about it yesterday that I'd have to do purple and black, or black and purple, red and black, or black and red, red and purple, or purple and red. Man, there's going to be a lot of different combinations, and I don't want to have to figure out all those combinations. Sometimes we just have to, but if you can use the complement, that'll really be helpful. So look for those complements within those problems. Okay, so there's our balls in an urn, and then we moved on to the fish yesterday. So let's do the same fish problems we did yesterday, except now let's find the probability for each one. So yeah, let me remind y'all what the complement is. So let me go back and do that again. Let me define that better. Remember that the complement of an event, so if I have some event E and I know the probability of that event E, that probability plus its complement, so the complement of an E, we denote it like this, or sometimes we denote it with a bar over the E, or some people will put a P with a C up there, the complement. There's lots of different ways to do that complement notation. But those two together, when I add the probability of the event plus the probability of the complement, I get 1. Or you can think of it this way, the complement, not getting this is equal to 1 minus the probability of that. So when we talk about complement, it's just the whole thing minus part of it. So that's what I mean by when I'm talking about complement. That's that definition. Let me draw those fish up here again. We had 4 red, we had 3 blue, we had 1 that we couldn't see, yellow or orange, and then we had 2 rainbow. My rainbow may not look the same as they did yesterday. I think that's what we had yesterday. And our experiment is to catch 3 fish. And we're going to do it without replacement. So we're not going to put them back in. We're going to catch them and eat them. Not putting them back in. So, I want to know what's the probability I catch 3 red. Now
Yesterday we put it into words. So that's a big deal. Is first we've got to be able to say red and red and red. But you have that done now. So if you do day 1 of the classical probability day 1, you have it written down in words. Now you just need to add the probabilities to it. So once we have the scenario down, then we can go back and say, okay, what is the probability that I get a red one on the first draw? So that's my next task, is to go, all right, how do I get the probability, what is the probability of a red one on the first one? So remember, it's the total number on bottom. So how many fish do I have total? Good. And then how many red ones do I have? Good. And I'm multiplying. Now I took a fish out. Here it is in my hand. There is one of the red ones right here. Here he is. So how many red ones are left? You've got the right idea, Cheesecake. It goes, from 4 down to 3 red ones. And I had 10 fish, but now I'm down to 9. And then I do it again, and it's going to go down again. So 10, 9, and then only 8 of them with 2 red ones left. Okay, I'm not doing any adding, so I can go ahead and simplify. I'm going to go ahead and simplify this problem. So this is 2/5, and this one is 1/4. Oh look, I can do more simplifying. See this 2 and that 4? I'm going to go ahead and simplify this 2 and that 4 to make that a 2. Now I can multiply across and I get 3 on top. Oh, wait a minute. This can simplify too, can it? This becomes 1/3. So you're right. On top I just end up with 1, and 5 times 6 is 30. I knew it must simplify because Adam had 1/30 up there. So it's 1/30. Perfect. So out of 30 times of catching 3 fish without replacement, one of those I should get 3 reds. I expect to get 3 reds. Let's go ahead and do our probability distribution. Let's make us a table. So the probability, first of all, let's look at the outcomes. If I'm catching 3 fish, how many different red fish can I get? Well, I could get 3 red. All 3 of my fish could be red. Or I could get 2. Or I could get 1. Or I could get 0. All right, so the probability there is 1 out of 30. So again, if I did this experiment 30 times, my frequency of getting 3 red, I would expect it just to be 1. All right, now let's do 2 red. Oh no, I'm still catching 3. Still catching 3, but I'm going to do 2 red. Remind me how we did that yesterday. Give me the words for it. Maybe we did a red on the first one. And not red, red, and red. Cool. Not red on the first one. And red, and red. Is that the only way to do it? Or we can move that not red around, right? We could do it on the second one. So we could get red and not red and red. Or that not red's got to go one more place. So red and red and not red. Hopefully that's what we did yesterday. Something like that anyway. Okay, once you have those words down, then we just put the probabilities with it. So what's the probability I get the not red on my first try? Well, there are 6 not reds out of a total of 10. And I have one of those not reds out of there. I caught it, made it. It's gone. So now there's a red left, 4 reds left, but only 9 fish in there. And now I've eaten a red and a blue, but not red. So I only have 3 reds left and 8 total fish. Or red on the first one is 4 out of 10. Not red, well, I'm down to 9, and then I'm going to be down to 8, so I can go ahead and put those on there. Not red, there's still 6 of them, but one of the reds is gone because I took it out here, so I only have 3 left. Notice that this is the same as that. They look the same, the tops do, even though they're out of order, it's still the same probability in the end. So now that we know that there are 3 ways, really all we have to do is find out this probability and multiply it times 3. But we'll keep going. Our red is 4 out of 10. We're going to go down because we're keeping one out each time, so without replacement, it's going to go down each time. And then the red on the second one only have 3 fish left, and then I still have 6 of those non-reds. So again, notice that it's all the same. I've just got 3 of those. So since they're all exactly the same, and I've got 3 of them, I could just multiply 3 times whatever the probability of one of them is. So let's go ahead and just simplify. That goes in there 2 times. This goes in there 3 times. Oh look, 3 times 2 gives me 6. So I have a 6 down here on bottom and a 6 up there on top. So I'm gonna cancel out this 6 on top with that 6 on bottom. That becomes 1. So I really just have 1/10 for all of those. And if this one's 1/10, and that one's 1/10, and this one's 1/10, it's just 3 of those, so it's 3 out of 10 chances. Or 1/10 plus 1/10 plus 1/10. Because this is going to be 1/10. My board is not big enough. That's going to be 1/10, and that's going to be 1/10. So the probability here is, I'll write it down here too, 3 times the 1/10, which gives me 3/10. So to get exactly 2 redfish, I've got 3/10. Okay, now what about 1 redfish? Maybe I don't have to erase it all. Because look back and see how we did 1 red. But I think I can just turn this one into a red and turn these guys into not reds. Because I could get a red and a not red and a not red. Or I could just move that red around. So now let's make this not red a red and make the other 2 not reds. And here, my red, not red, not red. So I've got one red here, one red there, and one red there, and I've got it in each place, at the front, in the middle, and at the end. Now I'm just finding the probability of each one. So the words were the hard part. Once you have the words down, then we just have to figure out the probability. Well, sometimes figuring out the probability is hard enough on its own. So to find the probability of a red, well, there's 4 out of a total of 10 of them. And not red, well, once I take it out, I'm down to 9 and 8 again. And there are 6 to begin with, but then once I take one out, I only have 5 left. Or start with 10, then I only have 9 fish, and then 8 fish again. Not red, I start with 6, then 5. And the reds I have 4. So again, it's going to be that same thing over and over again. It's just a matter of figuring out one of them. And once I figure out one of them, then the rest of them kind of fall in line. 5, 4, and, this is 6 and 5. Sorry. 6 and 5, and then there are 4 reds. So let's look at the probability of just one of those. So 4/10 times 6/9 times 5/8. That's just one of these, but they're all the same. I could do that 3 times because there are 3 different ways. They're all the same probability. So now 4/10 is the same as 2/5. 6/9 is the same as 2/3. 5/8, and I'm still multiplying it times 3. Notice there's a 5 here and a 5 there. Notice this 2 goes into that 8 4 times. And then this 3 out front really is over 1. 3 of them. So this 3 and that 3 we can simplify as well. Oh, and that 2 and that 4 simplify. This 2 on top and that 4 on bottom. So it looks to me like it's a half a chance. 1 on top out of 2. Is that what y'all got? 1 out of 2? We can always check ourselves with the probability distribution here at the end. We can check ourselves to see. Good job, guys. All right, so now let's do 0. So the 0 fish, 0 red fish. In order for me to get 0 red fish, there's really just one way to do it. I have to get a not red, a not red, and a not red. 0 red fish. I have to get a not red, and a not red in order for me to get no reds. So to get a not red on the first one, well, it's 6 out of the 10. I'm down 1. So now there's going to be 9 and then 8, just like before. But now, instead of having 6 not reds, I'm going to have 5 not reds. And instead of having 5, now I've taken 2, so now I just have 4 of them. And that's the only way I can do it, is not red, and not red. Okay, so now I'm just going to simplify this. We got 3/5. I'm going to simplify that. No, I can't. 5/9. And this is 1/2, but I am going to keep looking for things to simplify. I bet y'all see them already. Like this 5 and that 5. And this 3 goes into that 9 3 times. So on top I have 1, and on bottom I have 6. So 1 out of 6
1 out of 6 chance. All right, now what we're going to do is make sure. Let's add these up just to make sure, okay? We want them to add up to be 1 so that our probability, of getting 0, 1, 2, or 3 is all equal to 1. So here, that looks like my common denominator. It has to be at least as big as the biggest one. So it has to be at least 30. And 10, 2, and 6 all go into 30. So I multiply this times 3 over 3 to get to 30. I multiply this one by 15. And I multiply this one by 5. Let's add them up and just see, do we make it to 30 over 30? So that's 20 plus 10. Sure enough, hey, that equals 1. Yay! So we were worried about this, them looking funny. Maybe we're like, oh, I'm not sure about it. But once I get to this point, I'm like, oh, thank goodness, it does add up to be 1. Okay, now I'm going to show you one more, and then I know we're over time. So the last one I'm going to do for you is that at least and at most 1. So let's look at these fish just a little bit longer to do the at least and the at most. So I want to catch at least 1 red fish. And we talked about yesterday that at least means 1 or 2 or 3. I have to have all of it. So I'm going to take, and I've already done 1 and 2 and 3. 1 or 2 or 3. So that or 1 or 2 or 3, what I could do, since I've already done it, is I could add them all together. I could take 1/2 plus 3/10 plus 1/30 and add those together. Or another thing I could do is I could use the complement. Notice that the 1, 2, and 3 plus the 0 make up the whole set. And at least 1 is this 1, 2, and 3, and this is like the other part of the set, the guy that's left out. So I could just find the probability of getting 0 and subtract that. So I'm going to use that complement. That's going to be really handy later when we're trying to find at least 1, the probability of something, or at most. Using the complement is going to be super helpful. And the way we do it is we just find then the probability of 0 fish, which is 1/6. We already did that. The probability was 1/6. And we say, okay, the complement then, so the complement of that 0 is equal to the probability of 1 plus the probability of 2 plus the probability of 3. These things are the same thing. The complement of this is equal to those guys. So, and it's also equal to 1 minus the 1/6. So this is equal to 1 minus the 1/6. Make it 6 over 6, and you got 5/6 is the probability. So for those of you who added up the 1, which was 1/2, or let's do it with the 30ths, 15/30ths, or 9/30ths, or 1/30th. Notice that when we do that, we get 10/25/30ths, which sure enough is equal to that 5/6. So one way to do it is to do the 1 or the 2 or the 3, but another way to do it is just to look at the complement of it. So using that complement sometimes is super, super helpful. Then at most 1 red. So that for at most 1 we said was 0 or 1. In that case, using the complement isn't going to help us any. because here is at most 1. It's just that 0 and that 1. So the complement of it, though, is 2 and 3. It's just as much work to do 2 and 3 as it is to do 1 and at most 1. Yeah, we could do it. You could either add this one plus this one to get at most 1, or you could add this one plus this one and subtract it. So they're both the same. To find the probability of 0 plus the probability of 1, this is at most 1. Or we could do 1 minus the probability of 2 plus the probability of 3. And they should end up to be the same thing. Either way, they end up to be the same thing. Math made simple at Simpson Math.